I'm going to explain about the PyOT project. It means in English, academic research of Internet of Things, and it is a project made by 4 different scientific initiations, and it is made in the IoT laboratory at FEI, and it's guided by PhD Luciene Cristina Alves Rinaldi.
My name is Gustavo, and I'm also a part of the PyOT project. Nowadays, I'm a computer science student at Central University of FEI, and today I will explain about my model, is the security model at the PyOT project. This model is about to automatize the authentication at FEI. This project presents an embedded solution for controlling access and monitor real-time environments, or any other environment that needs access control. The project demonstrates an example of studying and comparison of some sensors like RFID, GPS, biometric, among others. A possible problem is that a student can pass the RFID card on an embedded device installed in the entrance of the classroom pretending to be another student without him or her being in the university. Therefore, a double-check system with a combination of RFID, biometric recognition, and a keyboard for password coding was initially analyzed. Then, a fusion of sensors was tested in real time like other solutions, like a camera for facial recognition.
Hello, I'm Celso. I'm a computer science student at FEI, and I'm also part of the PyOT project. I'm going to explain about the illumination module. This work aimed to automate and monitor the lighting of intelligent environments, similar to the application of smart houses, through an embedded device using IoT. These environments can be homes, offices, classrooms, meeting rooms, parking lots, libraries, laboratories, among others, using IoT sensors to save electricity. A multi-platform mobile application and a website were built to assist in the collection of data for the monitoring of information. This project specifically aims at the automation and monitoring of the environments, helping to reduce the financial and human resources of the institution and the IoT laboratory. As such, inspectors can monitor with a tablet or website by viewing the maps of all classrooms per floor.
I am Adriano. I'm also part of the PyOT project, and I'm also a computer science student. I'm going to explain about the parking model, and in this model, it is presented a solution that aims to dynamic control and monitoring of parking lots of companies, universities, malls, etc. Ultrasonic sensors were used on the wall in front of the vehicles to control the proximity and warn by identifying a light of an RGB LED if the garage is occupied, red, or free, green. The spots for disabled people are represented by a blue LED. A display at the parking lot entrance shows the number of occupied and free garages on the property, for users to know before entering the parking lot or in each spot, for example. At the entrance and exit of the parking lot, the gate is opened using step sensors together with ultrasonic sensors to detect the distance of the vehicles according to the proximity to the opening of the gate automatically. Another step sensor was used along with a camera to capture the images and make the administrative monitoring move automatically, as most condominiums and malls already do, aiming at the safety of the environment. Viewing the images is intended only for remote site monitoring. The treatment of the camera images is not the focus of this work. An Wi-Fi sensor was used for wireless communication to transfer information from the sensor to the server, which can be monitored via web and the cross-platform application. Using a tablet, notebook, computer, or a smartphone make it easier for administrators to access information, such as the number of registered users, daily, weekly, or monthly flow, etc.
Hello, I am Gabriel. I am a computer science student at FEI, and I'm also part of the PyOT project. I'm going to explain about the domotic model. This work falls within the automation team from the perspective of being related to devices to automate the routines of tasks of a house, simplifying the daily life of the people and satisfying their needs of communication, comfort, and security.
Thus, the concept
was demonstrated by presenting solutions of IoT as the automation of the control of a simple electric coffee maker according to the rules of the environment where it is inserted to reduce the electrical and energy, as well as the control of and monitoring of the air conditioning and a TV. This has brought environmental and economic benefits, as it aimed at automating the environment, helping to reduce financial resource through the reduction of electricity consumption. In addition, IoT sensors were used to monitor the environment through the construction of a multi-platform mobile application and a website on a Wi-Fi network. The user can access the application of the smartphone while at work and leave their home electronic devices, for example, scheduled or programmed to perform activities when they arrive at home after work. In the laboratory of the institution, the device was used with the purpose of turning on and off the electronic equipment according to the input or output of the students or teachers. Each has an ultrasonic sensor to detect the presence of people and real-time clock to check the time to turn on and off equipment such as the coffee maker, air conditioning, and TV. A relay necessary to keep the device working, infrared sensors to control the access to the TV and air conditioning, and a display to show the output information, such as the last coffee that was produced and know the appropriate time for consumption.